Today's lesson is on the polygon angle sum theorems. There are two of them, the interior and the exterior. But before we do that, we're going to review what the triangle angle theorem says. That's the one that says that the sum of the angles of a triangle equals something. Then we'll go over the polygon interior angle theorem. We'll talk about what it is and go over some examples of how we'd use it. Then we'll talk about the polygon exterior angle theorem, again, what it is and how we'd use it, and perhaps more importantly is when we'd use it or why we'd use it. Alright, so let's start out with our guided notes, put in today's date, and the objective of today's lesson is that by the end of the lesson today, we'll be able to find the sum of interior and exterior angles of polygons, and then use that information to calculate the measures of individual angles. So let's start with some review of the triangle angle theorem. And we'll start with a review of special triangles. There are two kinds of special triangles. There's the first one. Hopefully you remember this is a 30, 60, 90 triangle. There's another kind of special triangle. Hopefully remember that's a 45, 45, 90 triangle. And if we were to add up the angles of all of these, we see that 30 plus 60 plus 90 equals 180. And 45 plus 45 plus 90 equals 180. And in fact, that's the case for all triangles. The sum of the angles of any triangle is 180 degrees, and we can use that to solve some sort of a problem, like if we're trying to find that angle in this example. We know they add up to 180, so we can subtract out and find that the angle is 56. But the key thing to remember here is that the triangle angle theorem says that all triangles, no matter what kind they are, the sum of their angles equals 180 degrees. Now let's start talking about some polygons. So we'll start with this polygon. We're going to count up how many sides it has. It has 1, 2, 3, 4 sides. That's called a quadrilateral. And you say, how many interior triangles is it? How many triangles could I divide that shape into? So if I draw that line there, I see that I can divide into 2 triangles. Let's try another shape. If I count up how many sides, it has 1, 2, 3, 4, 5 sides. That's called a pentagon. And how many interior triangles? Let's find out. Count them up, 1, 2, 3. Here's another side. Another polygon. How many sides? 1, 2, 3, 4, 5, 6. That's called a hexagon. And how many interior triangles could I divide it into? Well, 1, 2, 3, 4. Let's try just one more shape there. Count up how many sides it has. This one has 8 sides. It's called an octagon. And how many different triangles could I break that up into? Well, the answer is 1, 2, 3, 4, 5, 6. Okay, now let's take that information and let's do some inductive reasoning here. That if we have a 4-sided, we get 2 triangles. If we have 5-sided, if we subtract 2, we get 3 triangles. 6-sided, we subtract 2, we get 4 triangles. And an 8-sided, if we subtract 2, we get 6 triangles. So using our inductive reasoning skills, we can see that the pattern for the number of triangles is the number of sides times 2. And since we know that each triangle has how many degrees in it, hopefully you remember that that's what we just learned, 180. And if we know that each polygon has n minus 2 triangles, where n is the number of sides, then we can use all this to determine a formula for the number of degrees in any polygon with n sides. And that formula would be 180 times n minus 2. Because 180 is for how many it is for 180 for each triangle, and n minus 2 tells us how many triangles are in that shape. So multiply them together and we get how many degrees are in a shape. And that formula or that concept is called the interior angle theorem. That for a polygon with n sides, the sum total of the angles of that polygon is 180 times n minus 2. Alright, so in our guided notes, the sum of polygon interior angles is 180 n minus 2. Now let's do some example problems to see how we would use that fact. So, for example, right here is one of your guided notes problems. It's asking us to find the sum of the interior angles of this shape below. So the first thing we have to do is find out what kind of shape it is. How many sides does it have? So let's count it up. 1, 2, 3, 4, 5, 6. So we know n equals 6. And our formula for the total interior is 180 times n minus 2. And if n equals 6, we can substitute in 6 for our formula there. Multiply that out, we get 180 times 4, which equals 720. So The sum of the interior angles of this hexagon here are 720 degrees. Let's do another problem that we now know how to do, which is find the measure of one interior angle. And this is a regular polygon, so we know that all the interior angles are equal. The first thing we have to do is find out how many sides it is, and we count them up. 1, 2, 3, 4, 5, 6, 7, 8 8 sides. So n equals 8. Our formula tells us it's 180 times n minus 2, where n equals 8 now. We can substitute in. So we get that that's n equals, 180 times 6. So that equals 1080. And so we know that the total interior is 1080 degrees, and the total number of sides is 8. If we take to get an individual angle, if we divide those, we take 1080 over 8, which equals 135. One final type of problem we can do is this type. It's asking us to find the measure of the missing angle, and this one, you'll notice, is not a regular polygon, but they give us the measures that we need to solve it. So the first thing we have to do, again, is count up the number of sides. It's 4, so n equals 4. So the total interior is going to be 360 degrees. So we know that this quadrilateral has 360 degrees, and that the different angles are 74, 106, 95, and x. And those add up to how much? Remember, they add up to the 360 we just calculated. So that is equal to 360. Add that up, subtract 275, and then I end up with my answer of x equals 85. So the measure of angle E equals 85 degrees. Now the question is, how many degrees are in the exterior of a polygon? We've answered how many degrees are in the interior of a polygon. How about the exterior? Well, imagine we have a polygon with n sides. So here's an example. This one has 4 sides. We'll just call it n. Here's an example. It has 3 sides, but again, we'll just call it n. 1, 2, then n, however many it is. And the question is, how many angles does this shape have? Well, if it has n sides, it has n angles. So we know it has n angles. The next question is, what is the sum of one interior angle plus its corresponding exterior angle? Let's draw that, and you'll see that that's an interior and that's an exterior angle. And so as a hint, they form a straight line, and anything that forms a straight line is 180 degrees. So the next question I could ask is, what is the sum of all interior angles plus their corresponding exterior angles? Well, if we have n such pairs of angles and they're 180 degrees each, then if I just multiply, I get that that's n times 180. So that's the sum of all the interior angles and their corresponding exterior angles is n times 180. Now I ask the question of, what is the sum of all the interior angles? And that's what we just learned in the interior angle theorem. And as we know that one, it is n minus 2 times 180. So now we know that the sum of all the interior and exterior angles is n minus 180, and of just the interior angles is n minus 2 times 180. So if the sum of all the interior and exteriors is n times 180, and the sum of all the interiors is n minus 2 times 180, what is the sum of all the exterior angles? That's what we're trying to figure out. What's the sum of the exterior angles? Well, the exterior angles simply equals the interior angles plus the exterior angles, both together, minus the interior, right? To find the exterior angles, if I find the interior and the exterior together, and then I subtract out the interior, I'm going to be left with just the exterior. So, what is the interior plus exterior? Well, we know that that's n times 180. And the interior, we know from our interior polygon angle formula, is n minus 2 times 180. Okay, well now let's distribute the 180. We distribute the negative, and n times 180 minus n times 180 cancels out. And we're left with 2 times 180, which equals 360. And here's the key thing. It's 360 no matter how big n is. If n is a triangle, if n is an octagon, anything in between or more or less, it doesn't matter. It is 360 degrees is the sum of all the exterior degrees. Okay? So the sum of all the polygon exterior angles is 360 degrees on our guided notes. So let's just take a look at that quickly. There's a regular triangle, and you can see that each of the three sides, or excuse me, each of the three exterior angles is 120. They add up to 360. Here's a regular quadrilateral called a square. 4 times 90 equals 360. Here's a regular pentagon. You can see that 5 times 72 equals 360. And this is the case whether it be where n is relatively small, like the ones we've seen, or if n is really big. You have lots and lots of angles, but each one gets relatively small, so when you multiply them all together, it still equals 360. And this is the case not only for regular polygons like the ones we see here, but also for irregular polygons. In this example, angle A plus angle B plus angle C plus angle D plus angle E equals 360, even though that's obviously not a regular polygon. So the thing you need to remember about exterior angles is they add up to 360 degrees, and that is called our exterior angle theorem. Okay, now that we know the exterior angle theorem, how would I use it? Well, here's an example problem. If we're asked to find the measure of one exterior angle of this shape here, well, the first thing I need to do is count it. It's a 5-sided shape, so n equals 5. And we know that the total exterior is 360 degrees. And so the individual angle is going to be the total exterior over the number of sides. The total exterior is always 360. The number of sides is 5. If I divide that, I get 72. So this is a 72-degree exterior angle. Now the question is, why would we ever really use that exterior angle theorem? Because I could always just find the interior angle and subtract. Why do I actually want to use the interior angle theorem? And sometimes we actually want to use it to find an interior angle. And why would that be? Well, let's do an example. So believe it or not, over there, that is a regular polygon. It has so many sides it looks like a circle, but it's not. It's actually a 36agon. I don't know what the name of it is. We'll just say it's a 36-sided shape. And we're asked, what is the measure of each interior angle of this regular polygon, this regular 36-sided polygon? Well, we know the interior angle theorem. We can always do it that way. The interior angle theorem just says we take the sum of the interior angles over the number of sides, and the sum of the interior angles is just 180 over n minus 2, and the number of sides is going to be 36. So I take 180 times 36 minus 2 over 36. That's the same thing as 180 times 34. I don't know my 180 or 34 tables, so I would have to calculate this out to be 6,120, and then I'd have to divide it out, which would not be easy, to get 170 degrees. So it's totally doable using the interior angle theorem, but it was a little bit difficult. The math was a little tedious. Now let's try the exact same problem, but this time using the exterior angle theorem. I know the interior angle is going to be 180 minus whatever the exterior angle is. Okay. And so, remember, we know that because we have interior and exterior, they add up to a straight line. So they are linear pairs, so they add up to 180. So the exterior angle, as we know, is equal to 360 over the number of sides. And in this case, the number of sides is 36. So 360 over 60 equals 10. So now we know the exterior angle is 10. Well, to find the interior angle, we take 180 minus the exterior angle, which is 10, which gets us 170. Okay? And that's the same answer as we got using the interior angle theorem. So the question is, why do I care? Why would I want to use the exterior angle theorem? Well, if you actually just look at the math, using the exterior angle theorem, you could do it all in your head. 360 over 36 is 10, 180 minus 10 is 170. That was easy. Using the interior angle theorem, again, the math wasn't particularly difficult, but it did take a little bit of time and effort. And so for ease, sometimes the math can be tedious using the interior angle theorem, and the math can be trivial using the exterior angle theorem. So if one comes like that, it's probably better to use the exterior angle theorem. But again, to be clear, you can always use the interior angle theorem to find the number of degrees in the interior of a polygon.